Alright. Alright. So the review session part 2 should now be working. Alright. So the review session part 2 should now be working. Alright. So the review session part 2 should now be working. Alright. It appears that this will be working now. So the review session part 2 should now be working. Alright. It appears that this will be working now. So the review session part 2 should now be working. Alright. It appears that this will be working now. So the review session part 2 should now be working. Alright. It appears that this will be working now. So the review session part 2 should now be working. Alright. It appears that this will be working now. So the review session part 2 should now be working. Alright. It appears that this will be working now. So the review session part 2 should now be working. Alright. It appears that this will be working now. So the review session part 2 should now be working. Alright. It appears that this will be working now. So the review session part 2 should now be working. Alright.
Okay, we should be ready to go.
This will be working now. So the review session
should be able to field all questions now. The new YouTube stream should have adjusted audio settings.
This will be working now.
So
the review session
should be able to field all questions now. The new YouTube stream should have adjusted audio settings.
Causes the echo.
Okay. So I'm just gonna keep. Should be able to field all questions now.
Keep the calculator.
Should have audio settings. Analyze your questions for your. So I'm just gonna keep. Should be able to field all questions now.
Keep the calculator.
Should have audio settings.
Causes
Analyze your questions for your.
So I'm just gonna keep.
Better. Should be able to field all questions now.
Keep the calculator.
Should have audio settings.
Causes
Analyze your questions for your.
So I'm just gonna keep.
Better. Should be able to field all questions now.
Keep the calculator.
Should have audio settings. Analyze your questions.
As a system
sounds
even
better.
Should be able to field all questions now. Keep the calculator.
There we go. That might do it. Better? Testing. Alright. Number 2 on Unit 1 review. Okay. So number 2 on Unit 1 review. So that's going to be, let's look at number 2 on Unit 1 review. That will be, tell whether each of the following functions represent y as a function of x. Okay? So let's copy, open up Paint, get a new paste. Alright, file new, don't save those changes, that's not going to work. Okay, so I'll just have number 2 on the left and Microsoft Paint on the right. Okay, number 2 on the left, Microsoft Paint on the right. Sorry, this is a new process, but hopefully once we get in the stream of things, I can do this to prepare for every single quiz and test the night before. So let's go to number 2. Alright. We're going to tell why each function is y as a function of s. Okay. So let's go to number 2. Also, by the way, I'm just going to let you know for number 2, I know that this type of problem, there isn't really, you need the background knowledge, but it's not going to be directly tested on the test tomorrow. So y is equal to 1 over x squared. This is a rational function, so it is a function. I want you to stop me or send me a remind if my explanation doesn't make sense. Alright, so that's 2a. For b, you can rewrite it so it's y is equal to negative 5x squared plus 2. That's a quadratic function, so that's a totally normal quadratic function. Or c, y is equal to x minus 3 squared plus 2. that's a quadratic function as well. For D, I can rewrite that as 2y squared is equal to negative x plus 22. I divide each side by 2. So y squared is equal to negative 1/2 x plus 11. And then for the last part, I take the square root of each side is equal to negative 1/2 x plus 11, which is going to be y is equal to the square root of negative 1/2 x plus 11, and so that's a square root function, so that is a function. So that's D. And the last one, the main one I want to go over is E, where with E, the absolute value of y minus 1 is equal to 2x, and so this gives us two state equations. Y minus 1 is equal to 2x, and negative y plus 1 is equal to 2x. And so that creates a problem where you have y is equal to 2x minus 1 and negative y is equal to 2x minus 1, so y is equal to negative 2x plus 1. This creates a graph where you have the slope of two lines. Actually, I think I made an algebraic mistake, but the main point is that you have two lines that fail the horizontal line test and the vertical line test. So not a function here. Alright. Let's go back to YouTube, field and YouTube questions. So once again, I am mandated by law to give the common assessment during its assigned date. Okay, so problem 9. So for problem 9, I'm finding e to the x plus 2. I'm finding domain and range. So e to the x plus 2 minus 5. This is one where I'm going to pull up Desmos. So the problem for number 9 is e to the x plus 2 minus 5. So the domain's going to be, in this case, all real numbers, because that's the set of all x values, and the range is going to be from negative 5 to infinity. And here's why. As you get x becomes a smaller and smaller number, that's going to be e to a negative number, which is going to be 1 over e to that number, and 1 over e to that number just becomes a really, really small number approaching 0. Okay. So here, if you're able to graph it, you can see the domain is all real numbers, and the range is going to be infinity. But once again, the main reason also why you can say the domain of e to the x plus 2 minus 5 is that with e to the x plus 2 minus 5, you're not dividing by 0, you're not taking the square root of a negative number, and you're not taking the logarithm of 0 or the logarithm of a negative number. So if that's the case where all three of these conditions are met, then the domain is going to be all real numbers. Okay. Number 13, part C. Right here. So 13C. Oh yes, that was one where I made a small mistake. So for 13 part C, here. So this is just a composition. 13C. F of x is equal to x plus 1. G of x is equal to the square root of x plus 2. And so C is going to be f over g of x, which is equal to f of x over g of x, which is going to be equal to x plus 1 over the square root of x plus 2. That's equal to f over g of x. So that's our answer, and you can just leave it like that. So once again, that's not going to be a directly tested question, but what that will be is you will have to do compositions / setup, be able to set up problems. Yeah, so I did mention that I did make a small mistake where I made a small mistake. I also put a correction video was already posted on Canvas. Okay. Loops. Okay, so this is for free, no donations. You can pay me in higher test scores. Test scores. How so people not in the class are clearly trolling the stream. Ignore them. Okay. Alright, so what we're going to do is go over transformations of functions, because transformations of functions is a really heavily tested standard. So in fact, I'm going to go do 21, 22, and 23 as example problems. So I actually, if you're going over with a pencil and paper, I get this down. So transformations of functions. Transformations of functions. Okay. You're going to have any function, what your main transformations are going to be are, let me go pull things back up. Negative a times f of x, so f of, sorry, let me be very clear here, f of negative b times x minus h plus k. This is a fully diagrammed transformation of a function. So if you have a negative sign on the outside, that's going to be a x-axis reflection. And then when you have a coefficient a that's not 1, if a is greater than 1, let's say a is 2 or 3, then you have a vertical stretch by whatever that factor is. So if you had a is equal to 2, you have a vertical stretch by a factor of 2. If a is less than 1, then you have a vertical shrink. If our coefficient b is negative, you have a y-axis reflection. Okay. And then when we have our coefficient b, so I'm going to have to draw this down here, but if b is greater than 1, you have a horizontal shrink, so it's opposite of our a, horizontal shrink. And then when b is less than 1, you have a horizontal stretch. So then you shift we're going to shift left right h units, and up down k units. And I want you to notice that you have a minus sign instead of h. So if you go left 3, that would be x plus 3. And if you go right 3, that would be x minus 3. Okay. Sorry, trying to... So let me go through the transformations of functions. They can actually give you a full breakdown of what's on the test. And actually after the transformations of functions, I might fully go down on what's on the test. So, but let's go to the transformations of functions. Let's do 21. Also, 21 was one where I made a small mistake by reading the problem wrong, so I definitely want to go over it now. For 21, you have, sorry, this is messing up, but you have the absolute value function shifted left 2, down 4, reflected across the x-axis. So first we have our initial absolute value function. So let's look at f of x. we're going to have our absolute value brackets. Alright, we have a reflection across the x-axis, so that's a negative sign on the outside of the parentheses. Okay? Then we're shifting left 2 and down 4. So we're shifting left 2, we'll have an x, and we do an horizontally, we go opposite of our original sign, so that'll be x plus 2, and then down 4 is going to be minus 4. So f of x is equal to negative x plus 2 minus 4. Alright, so that's 21. For 22, our original function is a square root function, so we'll have f of x. We'll definitely have that square root sign. But then we have a vertical shrink of 1/2. So I'm going to have a 1/2 as our coefficient, because vertical shrink, that means you have a value less than 1/2 on the outside of the function. Then you have a y-axis reflection. So the y-axis reflection is going to have a negative sign on the inside of the core function, which is going to be the parentheses. And then in addition to the y-axis reflection, we have a horizontal shift of right units. So that's going to be negative. And then our x term is in the parentheses. If we're shifting right 5, that'll be x minus 5. So that's 21 and 22. Okay. Now, 23. Alright. The graph has a vertical shift up 3, horizontal expansion of 4, a horizontal shift of right 1, and a vertical stretch of 2. So this is a lot going on here. So we have a vertical shift up 3. So first of all, we can express that as a plus 3 on the very end. Then we have a horizontal stretch of 4. So that should be equal to, we have our original square root quadratic function. We will have our stretch of 4. So that means we're going to have 1/4 as our coefficient on the inside of the function. Then we're going to have shift right 1. So we're going to have x minus 1 on the inside of the function. It's originally an x squared function. And then a vertical stretch of 2. So we have a 2 on the outside of the parentheses. Now, I want to make a list. Well, let me see on the questions out. So I need to filter through all the spam. Okay, chair, oh, none of this. 21 again. Okay, so let's break down 21. So all these transformations come from the transformation rules that are at the top. So I have start out with for 21, I start out with the parent function, the absolute value of x. Alright, but I'm doing some changes to it. I have a horizontal shift left 2. So when I have a horizontal shift left 2, notice that's x minus h. So if h is negative 2, left 2, x minus negative 2 is x plus 2. So that's how I get the x plus 2. And furthermore, I have a reflection across the x-axis. The x-axis reflection is a negative sign on the outside of the function. So that here, right here, is a negative sign on the outside of the function. And then I'm shifted down 4, and that's what a shift down 4 looks like. That's a minus 4 on the outside of the function on the end. So that's 21 again. Okay. So yeah, all this is spam, 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 spam. Spam, 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 spam. Okay. All right. So, well, I'm gonna go over 23 again because that was a special request. So yeah, 23. What's exactly going on here? All right. So we have a vertical shift up 3. So let's diagram that. That plus 3 right there, that's our vertical shift up 3. Okay? So that's an added term on the outside of the function. Yeah. Now, we have a vertical stretch of 2. Now, the 2 is going to be on the outside of the core function, and you're multiplying, you're not adding. So that's a vertical stretch of 2. And with the vertical stretch, it does what you think it does. 2 makes it bigger, 1/2 would make it smaller. Now we have a horizontal expansion of 4. So that's where the 1/4 comes in, because horizontal expansions or stretches, horizontal dilations are inside of the function. So the horizontal dilations are on the inside of the function, and you have that 1/4. So horizontal expansions are actually for terms that are less than 1, so it's for fractions. So horizontal expansions by a factor of 4, that's where that 1/4 comes from. That's our horizontal expansion by 4. Okay? Then the last thing is the x minus 1. That's going to go right 1, because that's on the inside of the function. And yes, yeah, so yes, so I guess Rivers, I guess people are spamming. I can't stop it. All right, I do want to spend some time on, if there's no specific requests right now, on going over description on the type of problems that is going to be on the test. So let's actually have me type out an announcement that's going to break that down, because I want to reward the people that are on the stream right now. So let's go let's do Common Assessment 1 problem types. Alright. So you're going to have 1, 2, 3. So you're going to have 3 questions on function transformations. Alright, 1 question on symmetry. That's, is a function even or odd? You're going to have to find the domain of a function. One question where you find the domain of a rational function. one question where you find the intersection of two rational functions. Find the range of a quadratic function. One question where you find the range of a quadratic function. One question where you factor a polynomial. Two polynomial long division problems. One is synthetic, the other requires long division. Okay, build a polynomial. One question requires you to build a polynomial from its factors, which you need to determine from its roots. Okay. One question requires you to find the end behavior of a polynomial. One question involves inputting data into your calculator and running and analyzing a quadratic regression. Just going through here. You have 3 inverse problems. Two composition problems with one word problem. Three, and then one problem where you find the domain of the inverse of a function. Okay, so these are the problem descriptions. This is a bonus to those who are watching the stream. And I'm actually willing to do a practice problem in any of these right now. So that is a full description. All right. Okay, let's look at the comments. Is anyone if anyone's asking any questions right now? Wow, these comments are pretty bad. Any questions? River is chair guy. I do not understand what's going on. Okay, 1 or 2. All right. Yeah. So I'm willing to do practice problems that are almost identical to the test based on these descriptions. So just call it out on the chat or send it to my revimped. But yeah, I will wait till a specific request. All right. Okay. Let's do one where you have to input data. And the best example of a problem where you have to input data, that would be the polynomial practice test. So here, Preston, with the polynomial practice test, the input data example would be this one, number 19. So in order to input data in your calculator, you would take, Hisha Ha says, hey, Mr. Lol. So to input data into your calculator, you go to Stat, you hit Enter on Edit, and then you put your inputs on L1. So I'm going to be 18, 22, 26, 30, 34, 38, 44, 52, and 60. Alright, so that's L1. So this is how you input data into the calculator. And this is L2, so the weight length is your input, the weight would be your output, so you put in 13, 26, 46, 75, 115, 166, 282, 492, 796. Okay, so that once you input the data, you go to Stat, Calc, and so this problem asks for a cubic regression, so that's right here, number 6. But if you wanted to do a quadratic regression, I want to do a quadratic regression, I would just do 5. So the problem on the test has a quadratic regression. This problem just has a cubic regression. So what I do, for the cubic regression, I enter, and I get ax cubed plus bx plus cx plus d, and it gives me like coefficients right here. So I rewrite the problem using those coefficients. So that's a new problem. And in order to find out what my answer would be, I'd have to input a specific value for x. So once you get the specific problem, You just have to write that polynomial and then plug in your input. Okay. Let me... My Instagram, people are talking about my Instagram should be closed. And I didn't post the YouTube Live link there, so I'm wondering how they got there. Edit profile. I guess I'll make my settings more privacy, account privacy. I have a private account. I don't know how people are finding me. Okay. Okay. So how do I get to the cubic regression? Very good question. So to get the cubic regression, first I have to put in my data. So Preston, after I put in my data, I go to stat and I go to calc. And I go to my whatever regression I'm trying to. So this problem asks for a cubic regression. But if I wanted to get a quadratic regression, I would just hit quad reg. So I will have hints for that test question on how to step-by-step instructions on how to use it. Okay. All right. Okay. Okay. Stop. All right. So, can you do one with input? What do you mean by an input? Can I do one with an input? Like numbers, an input. So here. How about this? Be very specific on, out of all the problems on the common assessment, which one you're talking about. Okay. Yeah, if you're actually like the cubic regression. Okay, so yeah, for the cubic regression, it's the input, like to input data on for regression, you just hit. So first of all, let me go to mode and then clear. So on my normal page, I go to stat, and then I go to edit, and then here I can just enter any data that's given in the specific problem. So I can clear L1, I can delete L1, and I can delete L2. So inputting data on my regression is just like putting in 1, 2, 3, 4, 5, and let's say this is data for just times 2, so that'd be 2, 4, 6, 8, 10. So that's just how you enter data onto your Chromebook. Okay. Okay. So that's a trigonometry problem. So that has nothing to do with the test. Okay, so do a polynomial long division problem and a composition problem. No problem. So let's do polynomial long division and composition. I feel like 3 people actually are learning and everyone else is just trolls. Alright, so polynomial long division problem. Let's look at the polynomial long division. So let's do the more challenging one where, so let's say you have a polynomial long division problem. Let me do, so let's say it's x to the 4th plus 3x cubed, plus 3x cubed plus 2x plus 1, all divided by x squared minus 1, okay? So you set that up, you have x squared minus 1 on the outside. And I'm just pulling this polynomial division out of nowhere. Okay? And then I have x to the 4th plus 3x cubed. I'm being very intentional here, plus 0x squared plus 2x plus 1. Alright? So to solve this problem, I have to take my leading, always look at my leading terms. These are my leading terms, and divide the inside leading term by the outside leading term and then multiply it through for our divisor. So x to the 4th over x squared is going to be x squared, and x squared times x squared is x to the 4th, and x squared times -1 is negative x squared. So that is going to, I'm going to take parentheses, put a subtraction on x to the 4th minus x to the 4th is 0. That becomes 3x cubed minus x squared plus 2x plus 1. I keep on going down. Alright, the next term that I can use is going to be x. So x squared plus 3x, because 3x cubed divided by x squared is 3x. So 3x times 3x squared is 3x cubed. And 3x times -1 is minus 3x. So 3x cubed minus 3x cubed is 0. And they have negative x squared. And then you have 2x minus negative 3x is going to be 5x. And lastly, in order to cancel out negative x squared, there will be x squared minus 3x minus 1. Negative 1 times x squared is negative x squared. And negative 1 times negative 1 is going to be plus 1. So I subtract the polynomial. Let's I increase this. Subtract the polynomial, and so I have negative x squared minus x squared is negative x squared plus x squared, so that's 0. Bring down that 5x, and then 1 minus 1 is 0. So I end up having 5x as my remainder. So this is my quotient. This is my remainder. And I can rewrite this as, so we can rewrite this as x squared plus 3x minus 1 plus 5x, that's our remainder, over our divisor, x squared minus 1. And that's what the final answer would look like. Okay, that's a polynomial long division problem. I'm going to look back into the chat. Okay. Okay, there's a lot of comments here, so I need to filter through and see what asking people. So I'm not sure how to. Okay, how to build a so let's do a composition word problem, and then how to build a polynomial. Okay, those are good problems. Okay, so let's do a composition word problem. All right. So for the a composition word problem, so you're going to see me write a test question real time for the composition word problem. So for the composition word problem, let's say f of x is a function of the points per game as the x input of an NBA basketball player where the output is a player rating. G of x is a function that function of the x input of player rating, which recommends the players a starting salary for any given NBA player. So this is literally me writing a question in real time. I didn't write this question, but what composition of functions would the Charlotte Hornets GM make to find out what he should pay his potential draftees. Alright, and so A would be G of f of x, B would be f of g of x, C would be f of x, and D would be g of x, and the answer here would be g of f of x. And the reason why g of f of x is the answer is because f of x takes points per game as an input and then creates a player rating, and then g of x takes the player rating and determines the starting salary. So if you're determining the starting salary, g of f of x shows the correct composition of a function. Alright, let's check the chat. Okay, let's let me look back at the chat, see if okay, Pokemon, yes. Yes, I'm slanting. I'll do a composition road problem. My favorite Pokemon's Articuno. Let's don't save. Let's just do it new. Okay, so I need to do a. Let's do the range of a quadratic function. I like that one. So let's say f of x is equal to 3x squared plus 2x minus 5. How do we find the range of this quadratic function? Well, I'm going to show you the test shortcut. We can take our calculator and input the function f of x is equal to 3x squared plus 2x minus 5, and I graph the function. Okay, and I should be able to find the range by just seeing what the minimum value is for the function, and then the range would be all values higher than the minimum value. So I'm going to go to calculate a minimum, choose a left bound point, and choose a right bound point. I'm going to guess. So I'm going to have a minimum of 5/3, right? So the minimum of the entire quadratic function. So a minimum is from a minimum value. I'm going to have a minimum at, what's that? Negative 1/3. Negative 5 and 1/3, because that's negative 5.33333. So the range goes the lowest y value to the highest y value. So that's going to be 5 times 3 is 15. So the range is going to be from negative 16/3 to infinity, because that's the lowest point, and it just goes higher from there. Alright, so that's the range of a quadratic function. The calculator writing is smaller. Oh, okay, that's not appropriate. The inverse of a function and the domain of it. Okay, so find the inverse function and the domain of it. Let me see. Yeah, let's do the domain of an inverse function. Okay, so the domain of an inverse function. Let's say f of x is equal to x squared. Ooh, let me change that. Let's say f of x is equal to 3x minus 2 squared plus 2, okay? So to find the inverse, I have x is equal to 3 times y minus 2 squared plus 2. Do some algebra, so x minus 2 over 3 is going to be equal to y minus 2 squared. So that means that take the square root of each side. The square root of x minus 2 over 3 is equal to y minus 2. And so lastly, y is equal to the square root of x minus 2 over 3 plus 2. So that's the inverse function. Is equal to the square root of x minus 2 over 3 plus 2 on the outside. And so now how do I find the domain of this? So find the domain of the inverse function. Okay, so the domain of the inverse function is going to be x minus 2 over 3. So all I have to do is to look at that term inside the square root and say that that has to be greater than or equal to 0. So I have to say x minus 2 over 3 must be greater than or equal to 0. Multiply each side by 3. 0 times 3 is 0, so you have x minus 2 must be greater than or equal to 0. Add 2 to each side. And you'll get x must be greater than or equal to 2. So how do you express that as a domain? Well, if x is greater than or equal to 2, your interval notation is going to be from 2 to infinity, and your set notation is going to be x such that x is greater than or equal to 2. Alright, so that's the that is the domain of an inverse function. Going back to the chat. Okay, lots of new comments here, so I'm gonna have to scroll through, filter. Why didn't you? Why didn't you set cannot equal to 0? Okay, that's a good question. So the only time when it cannot equal 0 is when you have a denominator. So I guess, yeah, I guess you. I guess that's actually true. If it's okay, so here's why I said it cannot equal 0, Preston. So very good question, but look at the denominator for the inverse function. There's no variable in the denominator, so the only thing that's in the denominator is 3. So no matter what x is, there's not going to be a 0 in the denominator because the denominator is not being manipulated at all. So the only way that you can get a 0 in the denominator is if you have a variable in the denominator in a problem. Okay. Okay. So yeah, yes, so Preston, the only way that you would set a problem where it can't equal 0, because the only way you're going to have a 0 in the denominator if you have a variable, because that's what it means, a variable. So if there's variable change, that's the only way you're going to have it set up where it's not going to be equal to 0. Okay. Show the work for the inverse that I did. Absolutely. Let me scroll up. So in the inverse, I started out with 3 times x minus 2 squared plus 2, and I switched the x and the y, and then did some good old algebra until I isolated y right here. So that's showing doing. Oh, is Zip and Zane Zelinsky? Yes. Yes, top student in pre-calc last semester. the intersection of a rational function. Okay, so let's find the intersections of two rational functions. So let's say, so find the intersection Also, I'm not taking the stream down. I'm going to help out my students, even if you spam up the page, because they can always ask me questions via Remind. Find the intersection of, let's say, 3 over x minus 2 and 4x over 7. So in order for, and that's, let's say, f of x equals 3x minus 2 and g of x equals 4x over 7. So to find the intersection, we set these equal to each other. So during the intersection, these are set equal to each other. So 3 over x minus 2 is equal to 4x over 7. And so we can cross multiply here. So 21 is going to be equal to 4x squared minus 8x. Oh, I chose a really hard problem here. Okay, oh well. So then this becomes 4x squared minus 8x minus 21. So this, I just made up a problem, but this is going to be quite hard. But if you, that's equal to 0. So I'm going to use my calculator to find the zeros here because I'm not using the quadratic formula. So we have 4x squared minus 8x minus 21. Graph that. Alright, so that means that I have two potential zeros. So I'm going to find my zeros. Calc, find the zero. Left bound, right bound, I guess is going to be right here. So I have a 0 of negative 1.5, 0, and I'll have a 0 of left bound, right bound. My guess would be 3.5 and 0. 3.5 and 0. So these are my two possible x values. So the answers here would be 3 over negative 1.5 minus 2. So the two solutions here for this intersection would be 3 over negative 1.5 minus 2, which would be 3 over negative 3.5. And then the other one would be 3 over 3.5 minus 2, which is going to be equal to 3 over 1.5. And I believe, 4 over 2. So that's just equal to 2. So we have, so for our two solutions here would be negative 1.5 comma 3 over negative 3.5, and then 3.5 2. So essentially To find the intersections, I solve for x by setting equal each other. That's our input. And then plug it back in to get the output. Alright, so this was a hard problem because I arbitrarily made it hard. So I'm going to go back to the questions and see what people are saying. Okay. Paul, I need brain cells. The test is tomorrow. Okay. You that sneeze though, bless you. He's not smart. Is there any? All right. It seems like I've done all the problem requests. Okay. Question on function transformations. So let's do it. Okay. I got a request to build a polynomial from its factors, so I'm going to do that problem. Then I'm going to do function transformations, and then I might call it a night, okay? So, build a polynomials from its factors, okay? So let's say, build a polynomials from its factors. Courtesy of Vivian. Build a polynomial from factors. Okay, so let's say a polynomial has zeros at -3, -1, 2, and 5. Okay? Let's say that these all pass through and this bounces. But I'm not going to complicate it for y'all. And I don't complicate on the test, so let's just say those are zeros. Build a possible polynomial. Build a possible polynomial. Okay, so when we build a possible polynomial, we have -3, -1, 2, and 5. So if those are zeros, our factors are going to be x plus 3, x plus 1, x minus 2, and x minus 5. So these are possible factors. So then we just do a whole bunch of algebra. This becomes x squared plus x plus 3x plus 3. So this becomes x squared plus 4x plus 3. And this term becomes x squared minus 2x minus 5x plus 10. So this becomes x squared minus 7x plus 10. Then let's keep this multiplying, so let's multiply the x squared throughout, so we get x squared times x squared is x to the 4th minus 7x cubed plus 10x squared, and then we do the 4x, so 4x times x squared is plus 4x cubed, 4x times -7x is minus 28x squared. And 4x plus 10 is plus 40x, and then we have a 3. So 3 times x squared is plus 3x squared. 3 times negative 7x is minus 21x, and 3 times 10 is plus 30. So a potential polynomial we could get is x to the 4th minus 3x cubed plus 10x squared minus 28x squared, so that would be minus 18x squared plus 3, so that would be minus 15x squared plus 40x minus 21x, that would be plus 19x plus 30. Okay, that's building a polynomial from the factors. Let me check back in with the chat. I turned that fan off. That's my AC. I can't turn it off. Okay. Combining factors, that's not good night. Is polynomial, so is polynomial long division, polynomial division, polynomial long division? Yeah, so that could be polynomial long division or syntactic division. Don't you have to do both transfer here? Is polynomial long division, okay, so transformations of functions. So transformation of functions, one thing is you can also scroll back in this feed to look at the transformations of functions. Also, you can try Khan Academy video on transformations of functions, or scroll back to my example problems. Make a new example. Fine. All right. I'll make a new example. Alright. So let's look at for transformations of functions, let's say f of x is equal to the absolute value of 3x, and it's reflected across the y-axis. Shifted up 2, shift up 2, and right 5. Okay. So if you're looking at this, a function like this, a y-axis reflection would have f of x, that's a negative sign on the outside. So the y-axis reflection causes this to happen. And then we'll look inside the brackets. Now that 3 coefficient needs to be factored out. Alright, and that's going to be of x minus 5. I believe it would be like that. And what that should do is keep the function so that you have that 3, but the x is isolated. So that's the transformation of functions. Let me go back to the chat. There's so many questions. Okay. I post Bong. Okay. So that's transformations functions. Okay, so let me do let me do one more transformation functions, then I need to call it night, and you guys need to call it night too, because you have a test tomorrow. You can have negative signs in the absolute value function. Yeah. Well, the y-axis reflection is going to be on the outside, so that's the y-axis reflection. All right. If you had an x-axis reflection, remember, if you had an x-axis reflection, so this is for the x-axis reflection, it would look like this, absolute value of -3, and then factor out that x minus 5. Alright. Then no. So let's do one more. Don't save. Alright, so let's do another one where you find the domain. So let's say Preston wants to we want the domain of a function where it starts with a radical. We double check the request. We need a square root in the denominator. Okay. Inverse function with domain and range, and preferably a radical in the denominator. Okay. So let's do of x is equal to the square root of x plus 1 over 4, and we need to find f to the negative 1 of x. So how do we find that? That'll be x is equal to the square root of y plus 1 over 4, which means that 4x is equal to the square root of y plus 1, which means that 4x squared is equal to y plus 1, which means that 4x squared is equal to minus 1 is equal to y, but I know that's not what you're looking for, so that means just the domain is going to be all real numbers. What you're looking for, Preston, is let's say you have the square root of x minus 5 over the 3 over x minus 5, find the domain, okay? So in this case, you make sure that x minus 5 is greater than or equal to 0, and that the square root of x minus 5 cannot equal 0. So in this case, you just add 5 each side. X has to be greater than or equal to 5. So that's one statement. The other statement is that square both sides. X minus 5 cannot equal 0, so x cannot equal 5. So because x cannot equal 5 and x has to be greater than or equal to 5, what we have here is that we can get rid of this term right here. So x cannot equal 5. So we end up just going to have a domain of x being greater than 5. So our domain would be from 5 to infinity. All right. Unless so that's the entire stream. Unless you have burning questions, let me go through all the questions. So, okay. Wait. So Preston says, wait. Let me scroll through. Look at addition questions. Okay, why did they get greater than or equal to? So the domain is always the most restrictive. So this created two inequality terms that you need to have. The square root of x minus 5. So first, the term inside the square root, that x minus 5 has to be greater than or equal to 0 because you can't have a negative square root. But also, this entire term, so let me do a different color, but the entire term in the denominator also can't equal 0. So that's what I did right here. And that's how I got these two statements, but I have to choose the most restrictive of the statement. Okay? So if I cancel out the 5, so if I have two statements, x has to be greater than or equal to 5, and x cannot be equal to 5. These two statements don't work together. There's one statement, only to make these both statements work, I have to choose the most restrictive. And so for x is greater than or equal to 5, I have to get rid of that equal to sign because that doesn't go with the second function, the second statement. All right. Okay. All right. Why did you grade? Is because because it cannot equal 5, so it's not going to work out. Okay. So in that case, that's it. Yeah. So any other questions before I go off? So definitely shout out to those trying to learn. Press F to pay respects. It's a Call of Duty reference. Okay, looks like those are all the. Oh no, so just Kate Allen, a reflection across the y-axis was within the absolute value bars. Okay. Alright, that's it. Good night all.